Okay, now I want to start to talk about making logical statements that depends on a variable. So these are called propositional forms, and this is uh, it's a one step more in the complexity, but we need this type of statements to talk about things we want to talk about in this class. So let's jump right to it. Okay. All right, so propositional forms are, these are sentences that look like logical statements, but it depends on the variable. So an example of propositional form is X is taking the paradox class, where X is a variable. So you might be able to plug in different people's names there. More mathematical type of propositional form might be something like x squared is greater than 0. Okay, these are almost statements, but it depends on what you plug in, right? For example, if I plug in name Cindy, there's no one named Cindy that's taking the course. So if I say the statement Cindy is taking the paradox class, it would be a false statement. Um, and if you kind of insert your name here, then as a person watching this video, you're probably taking this class. So then you are taking this paradox class. This would be a true statement. Same thing with here. For most numbers that I plug in, like 2 or -7, if I plug it in and square it, I'll get a positive number, except when I plug in number x equals to 0. Then 0 squared is not greater than 0, so that would be a false statement. Okay. So when we talk about propositional forms, there are things that make sense that we can plug it into X. So that's what's called the domain, or sometimes called universe of discourse, or sometimes called universe of discussion. These are all the things that we can plug it in to the propositional form and make sense out of it, right? And a lot of times it depends on the context of the discussion. So for example, if I'm looking at the propositional statement that P of X, okay, it makes sense to plug in names in there, or maybe UWT student names. Maybe that's the domain. So some people are taking this class and some people are not taking this class. But it doesn't make sense to plug in numbers here. Like you can't say 7 is taking a paradox class. That makes no sense. So numbers doesn't make sense plugging in there. So that's not part of the domain. It also doesn't make sense to plug in colors, right? Like blue is taking the paradox class. That also makes no sense. So the things that you can make sense of, that's the domain. And it depends on the context. So for example, maybe the domain that makes sense is just talking about students in this class, in which case everybody is taking a paradox class. Or maybe it's in the context of UWT students. So some of the students are taking this class, some of the students are not. Maybe you're talking about in the context of every single living being on this earth, right? So it depends on the context of the discussion, what the domain is. Okay. So what I want to cover now is that there are 3 different ways to turn propositional form into logical statements or true and false statements. So one I've discussed already, is to plug in X into a domain, from the domain into the propositional form. So plugging in names here uh, will make it either a true or false statement depending on what you plug in. Okay, so that's one straightforward way to make it into a true or false statement. Another thing you could do is use what's called quantifiers. So there are two different types of quantifiers. One is called universal quantifier. This is synonymous with the English phrase for all uh, or everyone. So in symbol, this is how you write it. So the symbol for all, it looks like a capital A that's upside down, right? So if I see this, for all x, p of x, uh, everyone is taking the paradox class. That's what that means, right? So this is true when every single element, every single person in the domain is taking the paradox class. For it has to be true for every single possible x. So this is true when every x makes p of x a true statement. Okay. So if the domain of this sentence is talking about people taking this class, then kind of by default, this is a true statement, right? Everyone is taking the paradox class. But if I'm phrasing this sentence in the context of all UWT students, it is not, it becomes a false statement. So if I say everyone is taking the paradox class, where the domain is all UWT students, then for all x, p of x is a false statement. You just have to give one example where this statement becomes false, then the whole thing will be false. Okay. So note that when you're talking about universal quantifiers, it's very difficult to show that it's a true statement. You have to either check it for every single element in the domain. You just have to kind of chug through and make sure everything is correct, everything is a true statement. But it is very easy to show that something is a false. You just have to give one example, just one thing in the domain that makes this sentence false. So all you have to say is like, oh, I could show that the statement is false because Cindy is not taking the class. So that means not everyone is taking this paradox class. So I'll just put that in parentheses. So easy to show it is false. You just have to give one what's called counterexample to show that it's false. But it's much more difficult to show that it's true. You have to make a general argument or check it for every single case that it's a true statement. Another type of quantifier is what's called existential quantifier. In English, that's there exists. In symbols, this is how you write it. So this looks like a mirror reflection of the capital E, right? Or maybe it looks like 3, but a little bit blocky. This is the existential quantifier. So there exists x, p of x. This is true if you can find one example where it's true. So this is true if you can give one example x in the domain makes this a true statement. So for example, if we go back to the same propositional form, X is taking the paradox class. So existential quantifier might be there exists someone who's taking this paradox class. And in that case, even when the domain is all UWT students, it is a true statement. You just have to give one example where the statement is true. So you could just offer yourself up as an example. Hey, I'm taking this class, therefore someone is taking this class. You just need one example to make existential quantifier a true statement. Okay, so this is kind of opposite of universal quantifier, right? You just have to give one example to make something true, but it's very difficult to show that this is a false statement. So you just have to, if you want to show that this is false, then you have to check it for every element in the domain, make sure that each X makes this a false statement. But given an example of something that's false does not make this existential quantifier a false statement. So I'll just write easy to show it is true and more difficult to show that something with the existential quantifier is false. Okay, so I've already said a little bit about it, but let's kind of practice of coming up with counterexamples. So today we talked about implication statements where it's in if-then format, where something implies something else. If I made a statement, if I bought Animal Crossing, then I have played it, right? So if you want to show that this statement is false, what you have to come up with is come up with a true statement that's pointing towards a false statement. This is the only way an implication statement could be false. So if you want to give a counterexample to a statement like this, you have to say, I have bought Animal Crossing, but I have not played it. It is not a counterexample to give a situation where I haven't bought Animal Crossing and I have not played it. That doesn't contradict this statement. So the first part of the implication have to be true for it to count as a counterexample. Similar to this, for universal statements, like everyone is in the paradox class, you just have to give one, if you want to show that this sentence is false, you just have to give one example where something is not true. Like Cindy is not taking the paradox class. Oh, there's a typo here. This should be paradox. Okay. So for universal statements, you just have to give something from the domain to make the whole statement false. But coming up with a counterexample for existential statement is not a thing. Just showing an example of something that's not someone that's not in the paradox class does not make the whole existential statement false. So in this case, you can't really give a counterexample. You have to check that everyone makes this statement false, right? So no counterexample can be given because must check for everyone in the domain. So I hope that made sense. So if you want to come up with counterexample universal statements, you can do it, but with existential statements, you can't really do it. You need a more general argument, or you have to check every single case. I hope that made sense. Let's jump to the worksheet. Okay. So this is an example. Sorry, this is a worksheet where you try to come up with lots of counter examples. So the first part is trying to come up with counter examples for implications. So remember, you can make implication false if the first part is true, but the second part is false. I want you to pause this video and try out this part of the worksheet. Okay. So it's remember for it to be a counterexample, the first part have to be true. So if you want to show that this is a false statement and this is a false statement, right? If I can dance, then I have $1 million in my pocket. You have to be able to show that you have an example where it is someone who can dance. So you have to, if you want to use yourself as an example, you have to show that you know how to dance, but you don't have $1 million in my pocket, right? Right, yeah. So I just want to say that it's not good enough to say, hey, I can't dance and I don't have $1 million in my pocket. That does not contradict that statement. It's not a counterexample. Okay. And I want you to try, so now I want you to try the second and the third part. Okay. For the following statements, say if the statement is true, if so, justify it. If not, come up with a counterexample. So not, and with the existential statement as well. If it's true, then justify it. And if not, come up with a counterexample. Try it out. And I think the tricky part of this is that sometimes there's different ways to interpret this. So maybe let's look at the statement right here. If you have every day, if you look at a universal statement, every day has a sunrise, depending on how you interpret this, the answer could be true or false. So if there's more than one way to interpret the statement, be clear about how you're interpreting it. And I think on this case, you can argue either way. In some sense, every day has a sunrise. It's rising, sun is rising somewhere. Um, but maybe if you argue that maybe this is from the context of what I see every day. So some day it's cloudy and you don't see a sunrise. So you could actually, I think you could argue either way, but just be clear about what you mean by your answer. And I'm not I'm not too picky as long as you justify yourself. There's more than one right answer here. Okay, so I think that's it for this worksheet. So please complete it. And if you have any questions, uh, log on to Discord and ask a question, or put it up on the discussion board. And I want you to make sure that you know that you could ask questions as well. Okay, so I will see you Friday.